Let's have an example on a normal random process. In this example, assume that x of t is a normal random process. The mean and autocovariance function are given. In that case, you could characterize the joint distribution of any arbitrary number of samples of your random process. So your random process is fully characterized. All the joint distribution of all number of samples are given. So in this example, we want you to calculate probability of this event. So that would be easy to calculate, because using these two, I can find the distribution of this guy and then calculate the probability, or we can ask other stuff. So the random variable s equal x of 8 minus x of 5, because they are jointly normal, their subtraction, which is a linear combination, also should be normal. So this is a normal random variable with mean of s. So mean of s is equal to mean of x of 8 minus x of 5. Mean of the first one is 3 minus 3 is equal to 0. Now, autocorrelation of that, sigma 2s, or variance of that, is equal to mean of x of 8 minus x of 5 minus mean, which is 0 to the power of 2. And if you expand it, you get mean of x of 8 to the power of 2, etc. And then you simplify it, you get 4 terms and this and that. So you get cxx of 8 and 8, this one and so on. So if you put 8 and 8 here, so you get 1. Then you get 5 and 5 here, and here you get 1, and minus twice e to the power minus 3. So this is going to be 2 times 1 minus e to the power minus 3. So so you can simplify it, you get a number like that. So you have more digits. This is 4 digits. So so you have the PDF, or you have the distribution. Probability that a zero mean, this is zero mean, normal random variable, this variance to be smaller than 1, is equal to integral. So this is a PDF from minus infinity to 1. So this is what you have, and then this you can try to calculate it. So integrating, because s should be smaller than 1, so it's from minus infinity to 1, and this is the PDF for mean, 0, and variance. So the integral, you could change this dummy variable, normalize it to make sigma 2s 1, and then what you get is you have to put this is a standard normal distribution with mean 1. So you change a dummy variable, you replace s by s divided by sigma s by 2. So if you replace that, if you replace s by minus infinity, your 2 becomes minus infinity, and if you put s equal 1, you get 1 over sigma s. So this will become the error function, and then if you calculate it for this value of a square root of that, so you get this number.